So we're going to go cover amplitude of sine and cosine function. So first, what I've written out is a cosine function, but there's something that you should know. Now the first one, I wrote y equals 1/2 cosine of 4x minus pi over 2 minus 1. And then the second one is very similar. Y equals 1/2 cosine of 4 theta minus pi over 2 minus 1. Now, the reason I wrote these two out, the only difference was the x and angle theta. Now, in the book, they use x, but given as like for quiz problems or practice problems, homework problems, maybe even on a test, if you see instead of x, it's angle theta, don't panic. It's going to be the same thing. It's just that in here, just like as x, what you're given, you plug it in. Now, if it's angle theta, you're basically going to be given in angles, in this case radians, and you just plug it in. Same thing with x. Most likely you get in radians. Sometimes you might get in degrees, but most cases will be radians. So even though it looks different, x and angle theta, it's going to be working the same process, the same operation. That's all it is. It looks different, but it's going to be doing the same thing. Alright, when we're doing graphing a sine and cosine function, now even though we're doing amplitude, it's always best to identify our a, b, c, and d value. So I'm going to use the second one. I'm going to underline the values for a, b, c, and d. So our a value is 1/2. Our b value is 4. Our c value is, even though it's minus pi over 2, we're going to use just pi over 2. And then our d value is -1. Now I wrote this one -1 because it's -1. Now it ties in, this ties in for our c and d value. This ties in from algebra 2 transformation. Since it's cosine and it's inside the parenthesis, same thing would apply to sine. If it's inside the parenthesis, our c value will be the opposite. So if it's minus pi over 2, it's going to be positive pi over 2. Now, if it's outside the parenthesis, since this one is -1, we're going to keep the same sign. But had this been a positive one, like a +1, this would have been a positive 1. Here, c equals positive pi over 2 because it was minus pi over 2. So take a note about that. Inside will be opposite, outside will be same sign. Alright, now the rule for amplitude, in order to find amplitude, which is pretty simple, is the absolute value of a. So our a is 1/2. So when we do the absolute value, it just be the same because absolute value makes the number inside become positive, so 1/2. So amplitude is equal to positive 1/2. Now keep in mind I said that the absolute value makes the number inside become positive. So keep that in mind. So since we're doing amplitude, this is our final example answer for this example. Alright, in our second example, it's y equals -4 sine of 2 theta plus pi over 4 and then -2. So like I said before, we're going to identify our a, b, c, and d value. So a is -4, b is 2, c is negative pi over 4. Now again, from just like the first example, even though in here it says plus pi over 4, I use the opposite sign because it's inside a parenthesis. As you can see, 2 theta plus pi over 4, it's inside the parenthesis. Since I'm getting my c value, and right now it looks like it's plus pi over 4, when I'm identifying my c value, I always use the opposite sign, only for inside the parenthesis. Now our d value, it's minus 2, it's going to be the same sign, so negative 2. Had this been a plus 2, that would have been a positive 2. But we always keep the number and the sign the same when it's outside the parenthesis. Here in this case, it's inside the parenthesis of the sine function. But our b value will stay the same. It's just only the c value that changed sign. B stay the same, a stay the same, d stay the same. It's just c will always be the opposite sign. Now, I wrote that amplitude is the absolute value of a. So now it's going to be the absolute value of our a value, which is negative 4. So negative 4, the absolute value, it only makes the number inside becomes positive, so 4. So in this example, the amplitude is 4. So that's all you have to do when finding amplitude in this example. Amplitude equals to 4. Alright, in our third example, we have y equals negative 1/3 cosine of negative 5x minus 5 pi over 6 plus 4. Now the only difference was in this example we have an x. But I said before, even though it's x or angle theta, the symbol is going to be different, but the operation is going to be the same. So let's identify our a, b, c, d value. So a, b, c, d. So a is negative 1/3, b is negative 5, right there. Now c, remember, what we have inside is going to be the opposite. So since it's minus 5 pi over 6, it's going to be a positive 5 pi over 6. And then d, outside the parenthesis, is plus 4, so a positive 4. So I want you to get in practice of identifying a, b, c, d, because while we're doing amplitude, when we're doing period, frequency, phase shift, then we'll be using all the other values, b, c, and d. And then for amplitude, again, the rule right there, amplitude is the absolute value of a. So in this case, our a is negative 1/3, and then we're going to do the absolute value of it. So it's going to make it, the number inside become positive. So it's going to be a positive 1/3. So again, the absolute value makes the number inside become positive, so it's going to be a positive 1/3. So that's our amplitude. And that is just the final answer for amplitude for this example.